Modulus and argument of complex number. First, we are going to discuss about the modulus of complex number. We know that if z is equal to x plus iy is the any given complex number, then modulus of z plus of complex number z is denoted by this symbol, and it is calculated by using mod z is equal to under root of real part of z bracket square plus imaginary part of z bracket square, that is it is equal to under root of x square plus y square. Geometrically it represent the distance of the point is geometrically it represent distance of z from origin. So for example, if we suppose if we consider here, suppose this is the complex plane, okay, and here is the complex, say here this is the real axis, and this is the real axis, okay, and this is an imaginary axis. Then, and suppose here is the complex number xy, pair xy, where xyz is equal to xy implies it is equal to x plus iy. So x is a real part of complex number and y is imaginary part of complex number. So here this is equal to the mod z, and which is nothing but the under root of x square plus y square. I am writing, okay, this is equal to mod z, and this is equal to square root of x square plus y square. So similarly, the argument of the complex number represented by the argument. Second thing we are going to discuss here, argument of the complex number, it is denoted by the symbol argz or theta, and it is again it is calculated by using here this argument can be calculated the angle which is made by the given complex number with positive or real axis. Okay, so this is what argument of z or theta, it is denoted by theta. Again, we know that if argument of z can have infinitely many values, infinitely many values, okay, or infinite values, sorry. Then because we know that if the theta is the angle, okay, theta is an argument, then theta plus 2n pi is also valid argument, valid argument. To make more specific, we are going to define here principal argument. So the principal argument if, okay, to it is this is what we can calculate. This is called the unique argument. We can calculate this unique value of argument. It is called the principal argument, and it is can be determined by the 4 different quadrants in which z can lie. So the principal argument is lie between the theta. The principal argument is lie between minus pi less than theta less than or equal to pi. So for the, if it is above the x-axis, for above the real axis, then it is angle theta lie between 0 to pi, and for below the x-axis, below the real axis, okay, or x-axis, it is theta lie between minus pi to 0. Okay, so again, suppose the principal argument can be calculated by using the location of the complex number. Suppose if it is lie in the first quadrant, say here is the z, then the argument theta is equal to, principal argument theta is equal to tan inverse of just y by x. Okay, if it is lie in the second quadrant, then this is what our principal argument, this is what the tan inverse y by x. But since we want the x theta with respect to positive x-axis, and therefore the theta principal argument can be calculated by using the theta is equal to, okay, pi minus tan inverse of mod of y by x. Okay, I am writing here theta is equal to pi minus tan inverse of y by x. Okay, so this is what tan inverse mod of y by x. This is what tan inverse mod of y by x. And if we subtract the mod y by tan inverse mod y by x from pi, we get and principal argument theta. Now for the next quadrant, for this quadrant, okay, this is what tan inverse of, mod of y by x. And if we subtract this angle from pi, minus pi, this angle is what, minus pi. So angle is minus pi plus tan inverse of mod of y by x. So this is what an principal argument if complex number lie in third quadrant, and last if it is lie in fourth quadrant, say here, then angle theta is equal to just minus tan inverse of mod of y by x. Okay, so this is all about the complex number. The principal argument of the complex number can be calculated by using the location of the complex number, whether it is lie in first quadrant, then it is only tan inverse y by x. If it is lie in second quadrant, then it is theta is equal to pi minus tan inverse mod y by x. If it is lie in third quadrant, then it is minus pi plus tan inverse of mod y by x. And if it is in fourth quadrant, then theta is equal to minus pi tan inverse of mod of y by x. So if we take the simple example here, if we take say complex number z is equal to 1 plus I, then here the modulus of z, that is real part of z, is 1 and imaginary part is 1. So x is positive and y is also positive, so the given complex number lie in the first quadrant. And here the modulus of z is equal to under root of x square plus y square, which is equal to under root of 1 square plus 1 square, which is equal to under root of 2. And argument of the complex number, argument of z, which is equal to theta, can be calculated, since it is equal to tan inverse of y by x, that is it is equal to tan inverse of 1 by 1, which is equal to tan inverse of 1, and we know that tan inverse of 1 is equal to pi by 4. You can also calculate the modulus, and suppose here z is equal to, say z is equal to, by using Maxima software, z is equal to 1. I want to zoom it. Okay, so z is equal to, say z is equal to 1 plus complex number 1 plus I is the given complex number. Then we can calculate its modulus of z by using the C ABS of Z, so you can see it is equal to under root of 2, and C ARG of Z is equal to say pi by 4. You can check here, it is equal to pi by 4. So the given complex number Z is equal to 1 plus I, then its modulus is root 2 and C argument is equal to pi by 4. Next, if we take the complex number, say next complex number Z is equal to minus 1 plus I, that is it lie in second quadrant. You can check here in the first example our complex number lie in first quadrant. Now in the second example complex number lie in second quadrant. So here again the real part of the complex number, x is equal to minus 1 and y is equal to 1. So here the modulus of Z is again x square plus y square, so it is equal to 1 plus 1, it is equal to under root of 2, and the argument of Z, it is theta, is equal to, so it is pi minus tan inverse of mod of y by x. So this is equal to pi minus tan inverse of modulus of minus 1 by y by x, 1 by minus 1. 1 by minus 1, since it is an absolute value, so absolute value is always positive, so it is equal to pi minus tan inverse of 1, which is equal to pi minus pi by 4, which is equal to 4 pi minus pi, it is equal to 3 pi by 4. So here you can check, if we take one more complex number, say Z is equal to, Z is equal to 1 minus minus 1 plus I, minus 1 plus I is a given complex number, and then I want to assign complex numbers. So to assign, just use double colon. So Z is equal to I minus 1 is the given complex number. Then by using the CABS of Z, you get it is equal to root 2, and CARG of Z, argument of Z, is equal to, you can check, it is equal to 3 pi by 4. It is equal to what? 3 pi by 4. So if Z is equal to minus 1 plus I is the given complex number, then its modulus is root 2 and argument is equal to what? 3 pi by 4. You can check here. Now next, if we take, say, if the complex number it lie in third quadrant, say Z is equal to minus 1 minus I, then here x is equal to minus 1 and y is equal to minus 1, that is x is also negative and y is also negative. So our complex number lie in third quadrant. In that case you can check here, our argument of Z is equal to minus pi plus tan inverse of tan inverse of mod of y by x. So the argument, the modulus remains same, mod of Z is equal to under root of 2, but the argument is equal to, theta is equal to tan minus pi plus tan inverse of mod of y by x. So it is equal to minus pi plus tan inverse of mod of minus 1 divided by minus 1, that is it is equal to tan inverse of 1. So it is minus pi plus pi by 4, so it is equal to minus 3 pi by 4. It is equal to, the argument of Z is minus 3 pi by 4. So if we use a maxima here, say z is equal to, since we want to assign a complex number, z is equal to -1 minus I is a given complex number. Then by using the, since we want to determine CABS modulus of z, so this is equal to root of 2 and C argument, that is argument of z, is equal to, you can check here, -3 pi by 4 -3 pi by 4. So it is what, -3 pi by 4. Next, if we take the complex number in fourth quadrant, say z is equal to 1 minus I, then here x is equal to 1 and y is equal to -1, that is x is positive but y is negative. So our complex number lie in fourth quadrant. In that case, again mod of z is equal to under root of 2, but theta is equal to minus tan inverse of mod of y by x, and here, so it is equal to tan inverse of, okay, 1 real -1 divided by 1, so it is equal to again it is equal to minus tan inverse of 1, and which is equal to minus pi by 4. So if we use the maxima again, say z is equal to 1 minus I is a given complex number, sorry, we want to assign it, so z is equal to 1 minus I, and if you use the CARG of z, then you can check the argument of the given complex number is minus pi by 4. If we take one more example, say z is equal to 1, say the complex number, take one more example, z is equal to 1 minus -1 plus under root of 3 I is the given complex number. Then here the real part of z is equal to, x is equal to -1 and y is equal to under root of 3, so x is less than 0 but and y is greater than 0, so our complex number lie in second quadrant, and therefore theta is equal to pi minus tan inverse of mod of y by x, which is equal to pi minus tan inverse of y is what, under root of 3 divided by -1, since it is a mod, it is equal to pi minus tan inverse of under root of 3, and we know that tan inverse under root of 3 is equal to 60 degree, so it is equal to pi minus pi by 3, so it is equal to pi by 3, so this is equal to 3 pi minus pi, so it is 2 pi by 3, and its modulus is equal to, the mod of z is equal to square root of -1 square plus under root of 3 square, so this is equal to 1 plus 3, so this is under root of 4, and which is equal to 2. Since it represents distance and which is always positive, so modulus of z is 2. So if we take one more, say here z is equal to -1 plus square root of 3 into I, okay, and this is the complex number, and if we use the CABS of z, okay, you can check it is equal to what, 2. So modulus of z is equal to 2, you can check here, it is what, 2. Now we want to determine what is an argument of the given complex number. So CARG of z, it is what, 2 pi by 3, and you can check here it is equal to same 2 pi by 3. We have also find this value by manually, and you can check it is what, 2 pi by 3. So this is all about the modulus and argument of the given complex number using maxima.